Hello, this is your host Brendan McNamara with another episode of Anomalous Experiences. Today I have the pleasure of discussing matters of weird science and strange magic with one Jason Cassibry, who is apparently one of the founding fathers of modern fusion and recently has begun dabbling in dielectrophoresis, which is one apparent route for gravity control through close manipulation of the electrostatic and ferromagnetic constants as a part of Einstein's field equations in order to manipulate K and thus G. And so we get into that, and we get into the state of the art surrounding this sort of experimentation, space travel, the multiverse, time travel, a lot of weird stuff, and actually have a lot of fun. If you enjoy it, don't forget to like and subscribe or leave some kind of feedback to that effect so that we can keep this going and bring the algorithm in and let people know about this content. And Jason is doing this mostly without funding yet or major support, so the more attention we can get to his work, the better. So I hope that you enjoyed this conversation, and we'll see you next time.
Hello there.
Hey, how's it going?
Oh, good. It finally worked.
Yeah.
That's it. We were like ships passing in the night for a little bit there. Upgrading my video. I had a bit of a panic a second ago too, because I have this monitor that's really finicky to start up.
Mm-hmm.
And I switched modes on it, like from analog over to digital for a second, like, oh, that'll fix it. And it shut down all my video.
Oh no.
So I just had to do a hard reset and come up from scratch. And I was like, oh my God, I hope like I don't, because it's Linux and it's finicky and sometimes it doesn't come all the way back up. And I'm like, I really hope I don't have to like jerry rig my system at the last minute. I would have done though. I would have still been like, we're still gonna do it, Jason. We're still gonna do
it. Well, finally we have some success, huh?
Yeah, no, that's great. I've been looking forward to this for a while. Yeah. Your presentation at APEC was really exciting to me.
Wow, thank you.
Mm-hmm. Yeah, no, it represents, to me, it represents kind of a grounding of these advanced concepts and bringing it into an experimental frame that is accessible, because you hear about what Charles Bueller and Drew are doing over there in Florida. Mm-hmm. And it's there, but it's a little esoteric. And there's this guy who's like, yeah, I did this with some sculpie clay. And I'm like, oh, wow. Okay. I want to talk to this dude.
Yeah. Bueller is among the more exciting of that group of people trying to, give us field propulsion. But I haven't seen them show anything yet. And I'm like, we could absolutely test what they're doing in our lab if we knew what they were doing. Obviously, they want to hold their cards close to their chest.
Yeah.
Everybody wants to be
NDAs.
Yeah. And that's understandable.
Mm-hmm.
But I haven't seen anything from them other than data. It'd be great if they had a picture or video or something. I'm not trying to imply that I doubt what they're doing. It's just, it would be nice if they could show us something.
Well, some movement would be cool. And because like showing it on a monitor in terms of like newtons or just pure force is cool, but it doesn't move the needle. Well, it moves the needle, but it doesn't move the people.
Yeah.
And people are like, well, show me the dang thing. So that's moving it from the counterintuitive to the intuitive, I guess.
Yeah.
To people being people, they just need to see something. I have the utmost respect for those guys, and I love what they're doing. And obviously, they want to keep their cards close to their chest, but one of the people, not maybe he's not in the academic or the engineering space, but one of the people that's been behind the disclosure of this technology for a long time is Stephen
Hmm.
Greer, and
Yeah, yeah.
he's said for many years, like, if you want to be the next Rockefeller of 0 point or anti-gravity, sorry to use the buzzwords, but you're not, you're just going to get stuck in the mud, and they're going to stop you because the patent system is broken that way. And the better route anyway is this open collaboration. And
I agree. Yeah.
repeatability is the lifeblood of science.
Hmm.
So if it can't be repeated in other people's labs easily and readily, then basically, for practical intents and purposes, it's not science. It's just some fancy data.
Hmm.
So you probably feel for that. So if you're working in that space, though, you're in a public university and
Hmm.
you're doing the things. So I totally respect that.
Thank
And
you.
but nobody knows about you yet, really, as far as I know. So this is exciting. And I'm excited. I'm still a novice where it comes to the mathematics, and I've been in a crash course on this for the last year and a half. I've been studying phenomena for a while. I had a passing interest in physics, pretty intense
Hmm.
interest in physics, but really hit the books in the last year or two since the congressional hearings. And I'm like, well, I
Yeah.
better
Yeah.
seriously figure this stuff out. And then people
Hmm.
told me, like, well, actually, we're much closer to modifying gravity than they'll have you believe. And I was like, oh, tell me more. So I've been on this journey of discovery. I'm open to learning as much as possible.
So what's since you've kind of been exposed to different things, who's come out with information or claims or maybe like really credible concepts or ideas that have really kind of influenced your thinking or optimism about it?
Okay. Um, well, even though he's kind of a nut, Jack Sarfati.
I was
Um,
going to ask you what you thought of Jack Sarfati. Yeah, yeah.
so what I really like about him is how he really breaks down and not like I don't really understand the full breadth of Einstein's field equations yet. I don't know who really, if anybody really claims to fully understand it, I think that they're deluding themselves. But
Hmm.
um, yeah,
Hmm.
the concept of modifying the dielectric and ferromagnetic constants,
Hmm.
um, the sorry, permittivity and um, permeability in the near field based on uh, how light behaves in matter,
Hmm.
connected to Maxwell's equations, Maxwell Heaviside, but the Maxwell Heaviside part of Einstein's equations that have to do with these factors as a part of modifying c to the fourth, as a part of modifying k, and thus g.
Hmm.
That's really exciting to me. That seems to just connect.
Hmm. Hmm.
That's where we stop playing with these electrostatics and electromagnetic fields, and that's you can look at the equations, and be like, oh, this is gravity. This at least is part
Hmm.
of that. Um, and even though it's not in matter, that you're changing the qualities of space time to behave like matter.
Right. Hmm.
And that's essentially what's happening in the corona of the sun as that light from a distant star is passing around it, as we discovered through the
Hmm.
telescope looking at the eclipse to verify relativity way back in the day, and so on. So that connects for me. And then there's I've been following Bueller and Oregama, and oh, it escapes me. I'm just so glad to not be toiling in the muck and the mire of Lazar worship anymore. I was broken out of that by Jeremy Reese some time ago when he was like, "Well, you really got to look at that again." Um, and not go chasing element 115 stuff. Um, like wow, lost so many years that way. But yeah, now that stuff in Jack Sarfati, Sonny White, Travis Taylor, few of these guys seem to be orbiting, no pun intended, a central star
Hmm.
that is this K modification bit.
Hmm.
And that's where I see you in that club, more or less.
I appreciate
And
that. It's very
yeah,
kind of you.
yeah. Well, I think you're all very close to something that everybody's basically it would seem obvious, but it's terribly counterintuitive and almost unbelievable. And I think and forbidden science, that's for sure. These things, sometimes I have to look over my shoulder and be like, do I have all my nose clean just in case somebody decides to stop me? Not to worry you or anything. um, like, sometimes it's like, what? Why are we being allowed to look into this? It's now, like, why now are we even being allowed to poke at these things when it's been so buried and fought
Yeah.
for such a long time? Is that entirely academic, or is there a deeper? There's been seems like a deeper push by the powers that be to keep this information away.
So I have a few things to say about that if you
Yeah,
want my so
yeah. No,
um
I'm all ears.
yeah. So from let's say a national security perspective,
Hmm.
the widespread panic that might ensue from UFOs landing on the lawn or that
Yeah,
kind of thing, I don't think is severe as it used to be.
right.
But I think that you do have to be responsible in that. Let's say someone has this breakthrough and that you could build an engine that you could put on an airplane that's this big and suddenly this thing could go Mach 20.
Right.
Well, that kind of capability in the hands of someone else where we haven't
Mhm.
matured it to understand how to counter
Like
it.
Al Qaeda or ISIS or something like that.
Yeah,
Yeah,
yeah, it would be a disaster. So you
yeah,
kind of have to slow walk your way into these
for
things and get
sure.
used to it.
Yeah.
So if it truly disrupted things
Mhm.
immediately, you would have a lot of resistance from a lot of different directions. So you do
Absolutely.
you do want to kind of like slow walk into it. But in terms of like a grand conspiracy, so I've talked to someone. I'm not going to say who, but if I had mentioned the name, you'd be like, "Oh yeah, I've heard of person," right? We had lunch here. It's like 4 or 5 years ago, and they had the privilege of studying this stuff and had clearances to do it. Like
Oh, I
they
think
were.
I know who you're talking about. They're in Huntsville. I know who it
I
is.
have no idea
Yeah.
what you're saying right now, but he said there's no he or she whoops said there's no real conspiracy. Different pockets protect their little pieces of it, but there's no organization. It's a disjointed mess,
Right,
basically.
right.
Yeah, and that uh, it's very very expensive to try to coordinate an effort to collaborate, and a
Mhm.
lot of times it gets killed by not politicians so much as mid-level administrators that somehow block it for fear or religious reasons or some other belief system or whatever.
Yeah,
It just
it's a mixture for sure
yeah
of
yeah
some genuine fear of national security leaks and some religious stuff. And I was just amazed that David Grush got his approval through on what he released. It seems
yeah
like some last minute bureaucratic um, paper pushing thing where they were just like, "Wow, we legally can't stop him. He's crossed all his T's and dotted all his I's, and he just squeaked that one through."
yeah
Um,
yeah.
and that says something about the administrative state. But yeah, I agree, and I'm a patriot. I used to be all for Flag Day and stuff. Unfortunately, I'm privy to a lot of the stuff that we've done over the years. And one of the things that soured me on it all was realizing as kid, I think I was 12 years old when I became aware of the level of technology we might have and how much it could change the world, and the fact that we were keeping it back. That
Hmm.
really, just made me angry, and justifiably so, I think. But I still think we have an interest in maintaining not hegemony per se, but like our own interests in defense and stuff. And
Yeah, yeah.
I think that the Chinese and the Russians definitely don't need any help. They're already working on this
Hmm.
themselves. So
Hmm.
right now it's a matter of keeping up with the Joneses and the Jings and stuff. It's a matter of maintaining parity. Like, we will
Absolutely.
get absolutely leapfrogged, and then we will be subject to domination by
Hmm.
others. So, whatever, it's not even about maintaining imperial dominance. It's about not being dominated, and about yeah, being able to enter this new world together. I think the implication of the technology is that, kind of like the nuclear bomb, uh, it's going to make a lot of warfare sort of redundant and extremely dangerous when you can warp into an area at, you said Mach 20. I believe it much faster than that if you can open a
Yeah,
wormhole, or,
yeah, yeah.
you talk about gravity modification. The implications are the modification of space-time, and faster than light travel, all that kind of stuff. We can just deal with the sublight stuff, and you're dealing with. I like your route that you're dealing with artificial gravity systems on conventional spacecraft. That seems safe, um, but yeah, the implications are still there. Of
Hmm.
the modification of space time opens up a whole Pandora's box of new, not just technology, but it changes the intuitive way we think about the universe. This is
Hmm.
technology that truly unlocks a new reality for humanity. Um,
It really
and
does. Yeah.
yeah, it doesn't make sense for us to behave in the same ways anymore. And that's what I hope, is that we can walk equitably into this new future with as little conflict as possible, because imagining that conflict is just, you think about, like, nuclear war was bad enough. Like,
Right.
and
Yeah. Yeah.
every day that goes by that we don't have one of those
Hmm.
is a blessing, right? There's so
Hmm.
many multiverse branches, if you believe in Everettian, that have come, and so many simultaneous branches where it's all gone to hell. And
Oh
we're in one
yeah.
of the few that hasn't. So I count my blessings. Um, yeah,
Yeah, I get into all of that. That part of me I don't let out too much in public,
yeah,
but the whole concept of probable realities and the eternal validity of the soul and all those kinds of things, I
sure.
completely buy into it.
No, and that's, it's good for you to be honest like that. I think even serious scientists need to have an inner life,
Yeah.
and the multiverse, it hasn't been readily proven, but I mean, Everettian solutions are one of the most intuitive, ironically, and require the least amount of obfuscation
Mhm.
as a solution to quantum mechanics, as far as I've heard, and as far as I've come to understand, and also allow us some of these nice things, like, they we they don't require these positivity conditions, because by having multiple time branches, you don't have to worry as much about closed time like curves, um, and grandfather paradoxes, and all this kind of stuff, because you just open a window to another universe, and you're not actually killing your own grandfather, you're killing adjacent used grandfathers, so no worries.
Yeah.
um this causality paradox doesn't need to be included. So that's, we can have some nice things that way, even though a lot of people might not like it. Like, you're creating all these universes. Like, I didn't create anything. You're creating issues for that. But yeah, yeah, I'd love to talk more about your experiments, though. I'm
Sure.
glad
Yeah.
to good to get this other stuff out of the way, though, for sure.
Yeah, yeah, absolutely. So, We kind of walked into it during the pandemic when we were shut down, and I had lots of free time. It was wonderful. I got so much done. I mean, the pandemic itself, not
It was a great
wonderful.
time for introverts the world
Oh
over.
my gosh, yes,
Yeah.
yes. But anyway, I was just going down I do this pretty regularly, just go down the rabbit hole on YouTube or other sources just to see what's new, what's interesting out there. And this guy did this simple trick with a soda straw, where he charged it up on his sweater, he put it up on a soda bottle, and he explained that attraction. He said most people just kind of dismiss it and say it's static electricity. And he said that's partially true, but it's really there's a body force there called dielectrophoresis, and then he explained it, and he talked about how it's done in medical applications. And I went and I started looking into that and realized that a lot of the applications of dielectrophoresis are in the hundreds of volt range on microscales. And I thought, well, shoot, we routinely charge caps up to capacitors up to 40,000 volts, and we have power supplies that go well above that. I thought, what can we do at that voltage? And can we do large scale aerospace applications with it? So I started looking into it and tinkered with high voltages to try to understand, just to kind of gain an intuition for it, and then wrote a model that would allow me to calculate fields and stuff like that. And eventually we got to where we could develop something that could cause a pendulum with different materials to swing, and we could quantify the force that we could generate on those objects. And so that's kind of how we walked into it. We have thus far not seen any forward momentum on anything that we can tell. It's reciprocal. In other words, if something swings this way, there's a pull the other way. It's just mechanically anchored to the ground or something like that. So,
Okay. So it's not like you haven't been able to create a persistent thrust in one direction that'll like move a car or something like that. It's you create a thrust and then observe the backswing.
So we haven't tried too much of that simply because large scale electrodes that you insulate, thoroughly with the right geometry, it's very time consuming, and we're all under contract to do certain jobs. And so we have to do these small scale things, and we've written some proposals to do larger scale stuff.
Right.
And like, for example, to NASA, the NASA Innovative Advanced Concepts. And we've proposed this concept twice as artificial gravity, and lost both times. We just lost again here. And the awards go typically to mostly East and West Coast. That's where most of the population is. And but it's always new sensors to do this new mission or things. There's very little really swing for the fences exotic stuff that they support. They do support some fusion. I've won some of those, before, but it's very, very competitive and hard to crack in with something like this. But I mean, I don't get it because we literally can demonstrate it. It's like, why do you not want to try to do this? I don't get it at all.
It's hard for them to wrap their minds around, I think, and maybe too good to be true. As far as a lot of people might be concerned. And I don't want to unincredulously believe. I'm giving the game away and how willing I am to believe in strange magic things, but that they're missing out for sure. And so I'm curious so you developed sort of a dielectric surface with sculpie clay, and you're coating that with high voltage electrostatic field. And so how does the actual apparatus, how is that set up?
Sure. So take a high voltage power supply, and you're going to need to see this. You're going to need something at least 10,000 volts.
Okay.
You can get one that's unmetered that'll go up to about 60,000 volts for pretty cheap on Alibaba.
So a Tesla coil, basically.
Tesla coil does not work well for this because we actually have a really high end Tesla coil, and we bought it with this in mind, and it doesn't work well at all.
Oh, all right.
And the reason is because while it goes to really, really high voltages, when you measure it with a non-contact voltmeter, you'll see the high voltage is a short little spike, and it's mostly at zero potential most of the time. So it's really loud, makes lots of sparks, and it's a great show, but it's actually not doing much.
So
At least the one
it's
that we
really
have.
noisy and it's not
Yeah.
so much signal. Um,
Yeah.
okay.
So we want to work towards that again, because maybe a Tesla coil can be used to pump something up to really, really high voltages if you can rectify that or something. So
Right. To make it
uh
do more deliberate work and
yeah,
less showy, lightningy
because
stuff.
yeah, I hate to go out down all these rabbit holes, but there was that artist, what was his name? Mark McClandish or something?
McCandlish, yeah.
McCandlish, yeah, that talked about how he found out about these devices that use
Hmm.
Tesla coils and high voltage plates, and so I mean that sits in the back of my mind as something that could be could
That's
be
a
useful.
complex story too. Some people say like he drew up some concepts and like then he was going around to different people saying like could this work this way? Could this work this way? And it's sort of
Mm,
like a little bit of wishful thinking shopping trip, you know.
ah,
And yeah, and then so it may well be that he stumbled onto some interesting materials, but it's also highly likely that it was a little bit of subjective sort of
hmm,
gardening too. So
yeah.
it's a mixed bag there.
Yeah, well, anyway, back to your question.
Anyway,
So, high voltage power supply, and you have the output in the ground. So, it doesn't matter how you orient it, but take those two leads
mhm.
and put one on one electrode and the other on the other. And the electrodes need to introduce some sort of asymmetry in the system. Two plates is not very useful. Curved plates is better. Something small like a stick and then another plate that also would be fine. But what you do is you coat those electrodes with sculpie or something to keep them from arcing.
Right.
And then the electric field that's left in the middle, in between that volume, the curvature of those fields is what introduces the force. So the
Okay.
force goes with the gradient of electric field squared.
So the electrostatic field is on the two adjacent, like the curved plate over here and
Hmm.
the stick over here, but your electromagnetic field is in the actual space in between them. Is that what
Ex
I'm
ex-
hearing?
exactly. So
Okay.
say take for example, let's say if I had a plate, this is my
Okay.
plate, and then here was ground or something. So you could kind
Hmm.
of imagine that the field lines would kind of go up like that and down, and there's probably some fringing effects. And
Right.
so this volume that's in here is where the force is, and the force usually is to the sharper end where the field lines coalesce. So usually the things are attracted towards that. It's not all cases are like that, but that's generally the case.
Okay. Okay.
Mhm.
That's starting to make a little bit more sense because the approaches I've like you're probably familiar with TT Brown. He had a dielectric surface and a ferromagnetic surface, both of those, and you're sort
Mhm.
of skipping the ferromagnetic surface almost entirely and just
Yeah.
going with two different. So that's the dielectrophoresis aspect. Is that where that name comes from?
So the dielectrophoresis aspect has to do with the way the force works, and it's mostly observable in dielectric materials. So in other words, in that space between your two electrodes in the volume, you've got if you have a molecule that's an insulator of some type, that it will polarize in that field, and so your molecule will flip. And let's say the sharp end is over here. This side experiences a stronger electrostatic force with its charge cloud versus this side, which is in the weaker part of the field. So it's like a tug of war on that molecule, and it goes that way.
Okay.
So it's really just an electrostatic effect, and it works best on dielectrics, but you can make it work on metals if you have an AC field, which has pulses that are like half rectified or something. So, in other words, if you don't have a pure AC field, won't do it, but if you use high voltage diodes and just get the top half or the bottom half, then you can pull metals to one side versus the
So it's
other.
an AC field, but it's behaving like pulse to DC, in other words, because you're removing the
Yeah,
other. Okay, so it's all
yeah.
DC, in other words, as far as the effect is concerned. But you can get
Yeah,
there with AC supplies. Okay.
that's right.
Okay.
Yeah.
Interesting. Okay, cool. And who's the guy that had the experiment that you mentioned with the bottle? What's that his name or YouTube handle?
So I have not been able to find him after about the first year. I should have, uh, written it down or something.
Uh,
It was just, it
Scrubbed from
wasn't,
YouTube.
yeah, right. Yeah. It wasn't someone that I recognized otherwise because I've seen, what's it, the Science Asylum and Smarter Every Day
Yeah.
and a host of others kind of within that community.
Right.
Yeah, and
The
it's not one that
normies. No, I mean they're awesome, absolutely awesome. But
yeah,
I don't see them scraping on this stuff yet.
no, no,
No.
no, no, no.
Even Plasma Channel he's got some wild stuff out there. But I would love to see him start playing with dielectric uh gravity control stuff. But
Yeah,
he knows where his bread is buttered.
yeah.
And
I was a little bit worried about him when he started putting deuterium in an accelerator,
oh,
just because.
yikes.
Yeah, I
Yeah.
mean,
Some of these
if you
guys take big risks.
yeah, I mean, it's probably not a significant dose. I don't know what he actually achieved. I haven't watched his channel lately, but yeah,
Mhm.
you really have to study that stuff a lot to understand, like, what the relative medical consequences are to your body if you
And
start.
what is the risk of that accelerating deuterium in that sense?
Well, if you accelerate deuterium and it burns, you make neutrons,
Oh,
and
that's
you, you
beta
know
decay.
Neutrons are neutron decay. So
Okay.
you've got the electromagnetic spectrum, which includes X-ray and gamma, which are
Okay.
just, gamma is higher frequency than X-ray. That's the only difference. And then you've got beta, which are just electrons that pop off.
Okay.
And that usually happens when a neutron undergoes a decay. So the neutron pops out of, or yeah, neutron decays in the nucleus. An electron pops out of it and becomes a proton, so it
Okay.
actually goes up in the periodic table a little bit, like one step
Oh, okay.
when it decays.
But
And
those
then
neutrons come out and they're just like billiard balls and like
yeah,
going straight
yeah,
through you.
a neutron that comes out has a really high
Very
internal
destructive.
consequence on the body. Yeah,
Yikes.
so we get bombarded with everything all the time, but it's just a matter of the dose and the dose rate, and so he's probably fine.
Probably. Yeah, yeah. It's kind of like when Nile Red a little while ago was playing with atomic trampolines, and he playing with beryllium, and really hope he didn't give himself berilliosis.
Oh my gosh, yeah.
But yeah, these guys, they'll do anything for a click. Science safely, everybody.
Yeah.
But no, that's really cool. And it's interesting you mentioned deuterium because I know you've done some work in fusion before. Um and I wonder what your approach has been, or if
Yeah.
I've followed Helion a little bit. That's where I
hmm
see the most promise,
hmm
rather than you're given tokamaks and stellarators going to do all this, recreate the energy of the sun just to boil water. I see that as kind of silly. But you might have different feelings there. I
Yeah.
know a lot more expertise, I'm sure.
Well, so fusion is has been my bread and butter since '99 when I started a PhD, and I'm probably mostly known for fusion propulsion, although I'm one of the main theoreticians and modelers for a couple of different concepts that are out there. And my area of expertise is primarily in magneto-inertial fusion, which includes uh, uh, concepts like what Helion is doing.
Okay.
Zap energy is another one. Uh,
Okay.
Helicity space, which they you may not have heard of them. And then there's a
Helicity, is that Helicity?
yeah, Helicity space. They're out in Pasadena, I think.
Okay.
And then what's another one? And then a
It's a
Pacific
little
Fusion,
mysterious.
which is one that you haven't heard, you may not have heard of yet. It's kind of a new up and comer, but they've got ties to Sandia, and I have lots of opinions about all of what they're doing. So
Okay.
yeah.
So it seems like you've followed these sort of things. So that double magnetic helix sort of idea is one of your core ideas. It sounds like that you've worked on here and there. Maybe not
Maybe not that
foundationally, but
specifically, but Helicity Space, they've got a long way to go before they get anywhere near break even, but they've got a really good idea in that they um, want to compress these jets and store energy in the magnetic field as it twists up. And then as it goes through a reconnection, which basically means if you have magnetic field lines that are anti-parallel, pointing in different directions, when they reconnect, they curl back together because of the way the currents set up and start running like little loops of circuit inside these plasmas. They accelerate out and release a huge amount of energy. So it's imagine like you're trying to start a fire,
right.
and all of a sudden you have all these matches go off at once in a mixture of butane and oxygen all over the place. So
Yeah.
Helicity is kind of doing that. Saying it is one thing, and then actually making experiment achieve that is another. But I think there's a lot of potential in what they're doing. I think that Zap Energy also is getting really, really close, but I think they're going to struggle to be I think they'll work. I think they'll struggle to be profitable, um, because they're basically a pulse reactor, kind of like tokamak. I mean, it's almost like a sneaky way of doing a tokamak because it's the first thing that we tried was these Z pinches, and so they
Mhm.
figured out how to make them stable.
Oh,
But it's really, really hard to sustain that level of current and not destroy your electrodes when you
sure.
do it.
Yeah, and I think that Helion is doing momentary pinches, and then so it's like a pinch boom, and then they're capturing the electrons that are flying away from the reaction with the coils on the outside of it, right?
Mm-hmm.
That's what I
Mm-hmm.
find most exciting because that's a solid state energy capture, just getting the electrons themselves out of
Mm-hmm.
it. Do you know more about that? About what
Uh,
they're doing there?
so it sounds like flux compression, which is where the plasma expands out and runs into field coils.
Mm-hmm.
Or it could be MHD generation. I'm not sure which one they're trying to do there, but Helion has a really good concept. Their reactor is not going to be high gain the way they've designed it. And in order to get something where you have like a big yield that comes out from a small energy investment, you have to have a liner around that event that you do that basically blankets the entire reaction, and then as that reaction takes place and the energy comes out, it lights and burns the surrounding liner of fuel that then can make a lot of electricity. So maybe they have plans to do that in the long term, but that's you have to have that if you're doing a pulse system in order to make it economical.
So if you were designing, you let's say you had an infinite budget, money is
Mhm.
no object. If you were designing a fusion power system for a, let's say, a gravimetric spacecraft that was going to Mars, or one of these low energy, not low energy, but subluminal warp drive
Mhm.
craft,
Mhm.
and you're doing a mission to Mars and back. What would
Yeah,
you design as a fusion drive system, a
that's a
fusion
very
power
good
system?
that's a very good question. One of them that I think would work pretty well is something along the lines of a Z pinch or a hybrid Z pinch with a liner that burns around it. And in fact, we have a couple of proposals in to NASA with some of our students where how you turn a Z pinch into a propulsion system has never been properly addressed. And we kind of had a facepalm moment this past fall when we were talking about it because you think of a Z pinch like this, and then you think of your nozzle as axisymmetric around that, and then you figure out, well, how do you get the circuit to come back? And one of us thought, well, what if we just turn it this way? Your feed to it is from the sides, and then your nozzle is sort of like a planar arrow. What do they call those types of nozzles? Arrow spike nozzle or whatever, where they kind of they're planar and go around it instead of axisymmetric. So that was something we thought, why didn't we think of this before? So that's something that we have proposed. My favorite fusion concept, I can say very little about because
That's as a drive system or as a power system for an electromagnetic drive system, or
both.
Both. Okay.
So yeah, basically, if you have your Z-pinch oriented, let's say this way, in and out of the page, and your nozzle is like that, so this thing goes off and then it explodes cylindrically outward. That plasma can run into field coils, which can do what's called flux compression. It squishes the field, and that can be picked up by those coils to recharge a capacitor bank. And if it has enough energy, it can do that and blast out that nozzle, so you get propulsion and thrust.
Okay, that's really cool.
Yeah, so it's hard to make all that
Star
work.
Wars stuff right there. Dang. Yeah. Millennium Falcon, eat your heart out. Yeah, no, that's powerful stuff. That's giving me goosebumps. Yeah, I know some people, my collaborators, are gonna love this conversation. Because we just jam about this stuff all the time. So man, now in terms of like connecting this to other concepts we already talked about, like I'm sort of seeing like the compression, maybe you're not using gravity modification to do that compression, but I'm seeing that the compression of elements as analogous to this increase in G and the expansion to the negative G, so to speak. Maybe that's not itself happening, but would these dielectrophoresis or other gravity modification approaches enhance the effectiveness of these fusion technologies in any way?
Wow, that's a great question. And I'm actually affiliated with a group that is looking at that.
Okay.
It wasn't my idea to combine warp drive and fusion together. Right. But this guy that leads it wanted to go that route. He thinks that's the best way to try to commercialize this stuff. And so while I thought that's a little bit, fusion is already so hard, but we're going to throw this on top of it. But I
might decided, be the straw that breaks the camel's back, so to speak.
So I looked into it, and I've studied some of the properties that are anticipated by field distortion, if you want to call it that. Okay. So if you can create a barrier so that let's say the neutrons can't get out, that's a huge breakthrough for fusion, not in terms of confinement necessarily, but just the materials challenges. Because even when we get these reactors working, we're going to have all kinds of problems because these neutrons come out and they're like bullets just shooting holes in your structure. And there's nothing that can take a deuterium tritium neutron. They're just like these hypervelocity bullets that just damage your reactor. You'd have to have
eventually you have some kind of self-healing containment.
Yeah, exactly.
Yeah.
So if you had like some sort of field barrier that could make them, bounce back in, it would need to be gravity or something that works on the neutron, because you can't just have an electric or magnetic field. They just don't care. Their electric properties are so localized, it's practically neutral, unless you kind of get down to their scale. Right. So that's an interesting one. Also, if you can reflect the radiation, that's a huge one. If you could hold all the energy in by having some sort of warp bubble so that it couldn't get out. Imagine like you saw this and it just looked like this black hole sitting there, but the reactor was on the inside. That would be great because if you could slowly add energy into that in one direction, like with some sort of energy diode, then fusion would be trivial.
Concept connect to some of the alleged footage, infrared footage of some of these UAP, by the way, that they
Oh,
look like a
really?
black hole, that's cold from the outside instead of hot from the outside sometimes. Yeah. But anyway, I didn't
Wow.
want to get off track.
No, 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 it's okay. So yeah, and the other thing too is if you could do that and somehow the field could be localized to compress and do work on that plasma on the interior, that would also be helpful. Yeah. So all those things are possible, or all those things, if possible, could help accelerate fusion.
Yeah, and
Definitely.
as an experimental offshoot of one of the ways it just occurred to me to really prove this gravity modification thing is like if you had an electron gun and you could generate a field that bent the electron gun, or sorry, neutron gun, and
Yeah.
you were able to make a bend in the neutrons, the arc of the neutrons, that could convince a lot of people that something real is happening.
Hmm.
Versus like, even if you were to dangle a piece of chicken from a string and move that around, that's still got
Hmm.
electromagnetic fields in that. But if it was just pure neutrons and you were doing something, that would make some heads turn. I feel um,
Yeah, that's
as a
actually a proposal that I'm working on with the group. So,
oh really?
yeah. So
My predictive modeling is working.
yeah, I know it's
Um,
spooky. You're tracking right in the same direction we are.
Used to do
So,
that in algebra class all the time, but I'm glad. Thanks for the vindication
yeah, yeah.
that I'm on the right track and not just
Hmm.
losing my mind. Um, no, I have 4 kids, so that's how I lose my mind. This stuff is where I feel sane.
Yeah,
Um,
yeah.
as my mom used to say, insanity is hereditary. You get it from your kids. Um, no, I love them, but they're a good problem to have.
Oh yeah,
Yeah,
absolutely.
no, they're the best kind
Hmm.
of challenge. But no, I love this stuff. It's so cool. Um, yeah, I'm almost out of questions. Did you have anything else you wanted to talk about? And
Well,
or
I had some comments I wanted to follow up. I agree with you because one of the first people that you mentioned is Jack Sarfati.
Mhm, mhm.
I've listened to him and I've tried. It's hard to find his papers or his presentations, but you can track him down. He speaks so confidently, like, "Oh yeah, we got this. Next year we're going to be flying around." And how many years has it been? We're all optimistic about our
Now,
things that
he's
we're
been
working
doing
on.
that. He's been doing that song and dance routine since the '70s. It goes back, yeah.
Yeah, okay, so
And
that's just him. But
and
if
and
you,
also instead of papers, he's got long email rants. And no, no,
but you're right. So I've when I started to get into this stuff a bit more, and I thought, okay, well, I need a foundation in general relativity. Boy, that was a lofty goal. So I had a couple of books and I read through them, and I didn't do the derivations. I try. I mean, I kind of understand the basics of the math and all that, but I tried to kind of get through all that to like what's this really saying? Like I just forget all the massive details and how these Christoph symbols expand out into bajillion different permutations of partial differential equation terms. Like what is it really saying? And all it is just curvature is equal to mass energy, and there's the coupling. And his point is that that coupling constant is terrible, but C is not constant in matter. I mean, that's the crux of it.
right.
And so I've kind of looked at all this and realized that even if it's problematic to go down this route, I really like the gravitomagnetic equations, the Maxwell-like equations, instead of general relativity, because even though it's like a solution in sort of like a linearized form, it's so much easier to work on, and I think we can make a lot faster progress towards an FTL drive someday, working on something much simpler. It's just a whole lot easier to get your head
Instead of
wrapped
starting
around.
from scratch with Einstein, we go straight to these modified equations. Are you
Yeah,
familiar with Todd Desiato?
no, that's
Okay,
a new one.
yeah, you should look into him. He's got whole paper warp drive from Maxwell, just from pure Maxwell. So
Oh boy,
yeah,
I want to
he's
read that
dealing with
now.
he's dealing with something he calls the EGM, electrogravitic magnetic matrix. And yeah, you're gonna like that one. He's an APEC contributor off and on.
Yeah,
Um,
somehow I missed that one.
yeah,
I haven't watched lately. I've
sort of
been
flies
kind of
under the radar. He's not too bombastic as a character. Just very nuts and bolts kind of guy. Very straightforward. But if you can get something by him, I guess you're onto something. Because he's a pretty serious fellow. But the fact that he's playing with these things is a relief because it's not all us wildcats. Not He's one to look into. What you said though reminds me. So there's a couple of people that have been playing with Maxwell Heaviside and Einstein and streamlining it. What do you feel? How do you feel about Hal Puthoff and the polarizable vacuum concept?
that one I haven't really looked at much. So that's another one of those areas where I I'd have to analyze it. Is the idea that you can say change the vacuum potential somehow and give it sort of a gradient or a curvature where
Very
you
much
have
exactly. Yeah. Yeah. He's
yeah
just basically likens the curvature of space-time to a gradient in electromagnetic potential and basically links those right up. And I'd be lying if I said that I understood all of this, but I'm kind of like a script kiddie, sort of playing with concepts, throwing
yeah
spaghetti at the wall to see what sticks. Um, I'm more of a surveyor, rather than an individual. I'm still deciding what lane I really want to pursue and what framework I
Mhm.
really want to get. But I see, like I said, I see all these people that kind of are poking at the elephant, that the blind men trying to feel up the elephant in the dark
Yeah,
room, um,
yeah.
and
Well,
they all have a little bit of something. But those are some frameworks that can be helpful to start to grok this. Uh,
one and grok it thoroughly we will.
right.
Um, so one of them that has not been explored much lately, but was by Winterberg, who his name kind of popped up. Like I actually knew Dr. Winterberg through his fusion uh, papers and seeing him at conferences. I've talked to him on a few occasions, and there's almost nothing I've done in fusion that didn't have his name on a paper in something that I was doing. I mean, he is just part of that dialogue. Um,
He
but
comes up in T. Townsend Brown's work too, I think, as
that's
well.
the thing is like I had no idea he had this other side of him looking at all of this stuff. And so I got a copy of his book on the what's it called, the Planck hypothesis. And I can't say I understand all of it.
Blank
Or
ether hypothesis.
that's it, yeah.
Okay.
And but the idea of negative mass, I think, is very, very intriguing. There's a paper by a guy named Bob Forward. You probably have heard of him, Robert Forward, uh, who did all kinds of different creative advanced propulsion concepts. But one of them was on a negative mass propulsion system. And I'm not so interested in the ones that could warp space time and create like a push pull thing with two big gravitational masses, but something where you had negative mass and positive mass and tension like a rubber band between them. I think is kind of interesting, something like that, because that's a practical, could probably do it in your garage sort of
Yeah.
demonstration.
Yeah.
And negative mass is now doable. Like there's if you build it, you can make materials that have that property under certain frequencies. That's been out for about 12 years now.
Oh, okay. So that's accepted.
Mhm.
Interesting. Because I keep hearing like if you even poke around this sort of warp drive and stuff, people are like, well, you need negative mass or energy, and that's super difficult to do, and we've never found it. And so that's BS, I guess. They're trying to throw sand in your face.
Yeah.
But do you have any reference to the paper or the study that showed that, or that I can?
The one that makes
I'm gonna
negative
probably
mass.
include a list of links in the video description when I do this. as much
So
as I can.
yeah, let's see. Let me I'll share this with
I'll
you.
Google
Oh,
simultaneously.
yeah. I mean, there's a quite a few papers on it. They're not in the context of propulsion, so I'm kind of giving away something that I think is very valuable. So,
Okay.
but feel free to look into it because I'm my goal is to actually do something meaningful enough that I give another APEC talk, and I'll probably give an AIAA talk on it as well. Um,
Yeah. Yeah.
and where is the? Oh, I see.
I've got a
Okay.
couple of yeah, I offered up an APEC talk to that. Tim put out a call for more material recently. I don't know if you got his email, but
I did.
he,
I don't have anything to say yet. So,
yeah, I was going to do like a survey of, the general state of affairs with all the different approaches, yours
oh
included,
yeah, that'd be very valuable.
yeah, kind of state of the art talk, and another one eventually on life, biology as a function of entropy reversal and
Hmm.
planetary control, sort of as like this is something that happens on planets in order to optimize climate and keep things from just drifting into chaos. But yeah, those are a couple, and I may end up. I've been I may have been asked to moderate the open mics
Oh,
soon.
okay,
Yeah. So
cool.
Tim's got a lot on his plate,
Yeah.
and he's continue. He's still going to be way involved, but that's and I have some experience there doing those kinds of talks, and I literally have work experience in managing and moderating Zoom conferences on a more open sort of
Oh,
level.
cool.
Yeah,
Yeah.
so that might be pretty cool. It's a lot, but I'm willing. Um, yeah, yeah. So that'd
Um,
be exciting if you could get another talk together. I highly encourage it.
yeah, yeah. It's going to take me a good 4 months of just slowly working towards something to see if there's enough there. And I don't want to give a talk until I have an experiment. So,
Okay,
and I've already purchased everything I would need to do,
right,
or
right.
most of it. So, but it's a matter of just, putting it together and all that sort of thing. Um,
Well, Poop,
but
you could just give one on the fly about fusion any day of the week, I'm sure. But it would be cool that your magnum opus, I believe, is this gravity control stuff. It would be really
I,
cool to see more.
Yeah, yeah, we're just trying to get all of this funded at a level. Like what I need is a full-time person in the lab, but it costs 300,000 a year at the university to have a good person, to do that. Because
Hmm.
otherwise it's just me, around teaching and then our undergrads and
Hmm.
grad students. It's
Hmm.
just hard to make progress. But um I wanted to ask, so during the APEC meeting, those guys running their labs. What, who are they? What is that? Like, is that some kind of consortium? Like, who's that brain
Um,
trust?
Falcon Space, are you talking about Mark and Jared and so forth?
I guess, yeah.
Well, besides Drew, obviously has his own thing going on, right?
Hmm.
That yeah, and Falcon Space is another thing. I'm not entirely sure. I think that they have some funding,
Hmm.
and it's independent. That's about all I know. And that so they're an independent research consortium that
Hmm.
I think Jared's affiliated with Mark and vice
Hmm.
versa. And then Jeremiah Pop has his thing also, and I don't think that he's Falcon Space. I think he's also got his own thing, and I think he has a
Okay.
private funder
Yeah.
to just
Hmm.
play. Yeah, God, I wish I
Yeah.
had that kind of.
Right. I know.
God, send me wealthy benefactors so I could just play with
Yeah.
gravity all day and night, please. I promise I'm not going to irradiate my children
Right.
or myself. No, that would be so cool. And I think that they've got something going on there, but the basis of that financially, I couldn't shake a stick at. It's a
Yeah.
question for them.
But
I'm
it's
sure they're
a
pretty cagey about it.
Oh, I'm sure. Yeah. No, they seem like a very, very bright, highly engaged people. It's good to see that there are folks like that that have like dedicated
Yeah,
resources
they're
to
going
pursue them.
they're playing with just about everything that comes across the desk.
Yeah.
Just trying this and that. More or less throwing spaghetti at the wall to see what sticks.
Hmm.
I kind of wish that they would go heavy into one particular thing and push that. But the problem is who knows what that is?
Right.
Who knows what ends up panning out, right? So
Yeah.
that's why they're trying everything. I think that the other day they had some massive experiment where they were trying to replicate the 3M event. I don't know if you know what that
Yeah.
is.
Right.
And
Yeah.
they made a massive um uh tape reel basically with Kinects in their lab and some massive voltage applier and they were applying electrostatic voltage to
Mhm.
this tape that was going around and it was just something to see, man. And sending like ping pong balls through the field to see if their
Mhm.
trajectory altered, but they were doing it live and it was nuts. um but man, like talk about a dream come true to every like tinkering kid that is
Oh,
like
yeah.
wish they could just play with Kinects all day in their laboratory. And I'm jealous. I'm
Yeah.
jelly, honestly.
Yeah. Yeah.
um no, but they're super cool. Another, well, they one thing they did recently is sort of um soft replicated the B field Brown effect and vacuum chamber.
Oh.
Yeah, they had this sort of pair of thrusters that were going around um on not a pendulum, but it was direction thrust around in a circle.
Mhm.
Um
Mhm.
and they took all the energy, or they took all the air out of the chamber. It was kind of in a bell shaped chamber,
Mhm.
um,
Mhm.
clear, so you could see into it.
Yeah. Yeah.
And these two little rocket looking things going around in a circle.
Hmm.
And allegedly they were using just electrostatic control of the B field Brown effect. And they were differentiating that with ion propulsion, and that like apparently according to Mark, the ion field propulsion works oppositely to B field Brown effect. They require the same basic materials
Hmm.
to do, but the ion, so if there's air in the chamber, and he
Hmm.
showed this live, if there's air in the chamber, the whole thing moves in an opposite direction.
Really?
Then they
That's
took the air out of the
interesting.
chamber, it
Uh-huh.
moves the other way, and less speed, but there was definitely movement. So he
That
was
is
able to show
interesting.
the difference between ion propulsion and
Hmm.
B-felt Brown as alleged. So that was
And
very cool.
was this all these demonstrated in recent like APEC meetings that are on YouTube? I'll have to
Yeah.
check it
That's
out
it's in
then.
the recent. I think this was last month.
Yeah. Yeah.
And they were demonstrating that live. And I think a few of them met up in New Jersey.
Hmm.
Jared and Mark, and I think Tim was there, and Dan Davis was there, and a few people actually collaborated on this rig. It was pretty cool. So it's definitely a group spirit project
Hmm.
to make this thing. Now, the one thing that might seemed a little, I was still they had a red cord going around it around the outside, and that seemed to me like some people that might think that you're doing electromagnetic propulsion there might think something about it, but they said that was just to control the Coulomb attraction, and take some arcing potential off. They needed to do that, but the whole thing seemed really, really interesting, and the fact that it changed direction when they took the air out, that
Yeah,
was that
that's
was really far up.
unexpected.
Yeah,
Yeah.
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 So that begs the question about like potential actual applications for this technology. If you have B-field Brown thruster on
Mhm.
on like a eVTOL or something like that. If you'd have to invert the voltages in order to, like, if you're going from atmosphere to out in space, or if you would have to enclose that somehow inside of your, like inside of the fuselage of your, that would really be demonstrative of principle as well. If you had a thruster that wasn't even connected to the atmosphere,
Right.
it was just
Yeah.
enclosed in something with its own shielding, and it was just
Hmm.
creating thrust in like the this direct center of your craft or something like that. But like if you, or if you had to, I was talking about this with some people. Like if you had to vertically flip your thrusters,
Hmm.
like you had ion thrusters, and then when you got to space, you'd vertically flip them around
Yeah.
to
Yeah.
make it work. But yeah,
Or just maybe just reverse polarity if that works.
yeah, that too.
Hmm.
Yeah,
Um,
much easier than trying developing a whole physical flipping system. But
but
it's
if you,
exciting stuff.
yeah, like a lot of the claims that have come out over the years, and this includes like the, what was it, the Q drive, the one that Sonny did.
Hmm.
Yeah, they all produce like just like these micronewtons of thrust, which could
Right.
be, hand waved, into anything. But if you can get something where you can observe motion
Motion.
like
Yeah.
that,
Mhm.
that changes it. If you can get into the
Yep.
millinewton up to Newton range, you dramatically change it. So even if on the ground it's not strong enough to, say, replace a vehicle or helicopter or plane or whatever, my gosh, out in space, if you suddenly have the ability to not
Yep.
require propellant, the rocket
Yep.
equation just you just completely sidestep it, and your final burnout speed is limited to how much energy you carry on board. If
And
it's a
there's
reactor, you could go, I mean, you could go sublight speeds over time anyway.
there's real application there too. I think that's where Charles and Drew are having their most promising potential application is in keeping satellites in orbit without, propellant, right? So
Yeah.
when satellites run out of propellant, I'm sure they have to just basically crash them.
Yeah.
But
Hmm.
that apparently I've heard is causing damage. It's renewing damage to the ozone layer. So having all of these Starlink satellites in orbit and we're crashing them all, something about, I think, magnesium burnup in the atmosphere is
Oh,
causing an
interesting.
ozone depletion. So
Hmm.
there's real sustainability implications to being able to get a propellantless drive system embedded in these satellite applications, even at the micronewtons of thrust over a long period of time that builds up, right? So
Hmm.
they
Hmm.
can even their system has some promise, but especially if you can show a result. And yeah, again, with the human psychology, you could show lines on a graph or on a reader, and the
Hmm.
person, if a person knows what they're looking at, they can say, oh wow, that's really interesting, show me
Yeah.
more. But most people will be like, I don't see anything. And just seeing the motion, seeing
Hmm.
something moving, that's your kitty hawk moment, so to
Hmm.
speak.
Right.
um
Yeah.
that you really need to get people on board, especially the money people.
Hmm.
That's it's kind of a chicken and the egg situation. It's like, how do you get
Right.
there without the funding? How do you get the funding until you're there?
Hmm.
It's really tough. And that's, I feel like, a big part. A lot of what people chalk up to some sort of conspiracy. Not that there isn't some sort of conspiracy, but a lot of that probably is just how difficult it is to do this stuff,
It is.
and get enough results to get more money to do more stuff.
Hmm.
You can probably
So,
testify to that.
oh yeah, yeah, absolutely. So I'm sure you're busy. I'm going to have to go shortly, but just
Yeah,
before we go, you'd mentioned Greer. So you think he's right? You think there's going to be this big disclosure
I
soon,
think
or?
my friend Dan Davis said recently, put it very, very well. He said disclosure is a process, not an event. And I feel
Hmm.
that very strongly. That could be what we're seeing with the drones, multiple
Hmm.
kinds of drones, and We've got drones that appear to be man-made technological that are exhibiting some sort of
Hmm.
possible gravitic propulsion. We have the plasmoids and the UAP all in the same breadth of time and
Hmm.
space up there. And that is some sort of soft disclosure, whether it's being readily explained out there in the media. It's definitely causing people to have a second look at all this.
Sure. Yeah.
So I don't know what all exactly is going to happen. Trump said that he's going to release some stuff once, on the 21st. He says, we have so many drones. I'm gonna put it all out there. Um, y'all gonna be so amazed at how many drone stuff. Um, but I don't know um, exactly. And everybody, I think the one thing I can say for certain is that everybody who thinks that there's going to be some massive drop and just basically Jesus parting the clouds for
Right.
disclosure,
Yeah.
I don't believe in that anymore.
Hmm.
Of course, I'm open to being proved wrong. Of course, now that I've said it like that, I probably will be knowing the universe and it's how it likes to treat me. To be like, see here, bam, and I'll be glad if that happens. But
Right. Oh yeah.
I
Yeah.
think
That's a.
it'll be this unfolding process, and what we're
Hmm.
doing is a part of that.
Hmm.
Uh, growing to understand these concepts as private citizens uh, is a big part of that because we're bringing bringing the stuff that you see up there down to earth and explaining it
Hmm.
in terms that we can understand, whether it's being done by extraterrestrials or other humans from our own timeline or other humans from other timelines or other
Hmm.
species that of terrestrials and maybe not human that have evolved on other parallel timelines. Or once you open the Pandora's box to like I said, gravity modification, space-time manipulation, closed time like curves not meaning much,
Hmm.
multiverse travel, it all, you deal with the Penrose diagrams and taking a faster than light drive a scant to an event horizon and do a couple of things like that. You're into bridging into other universes and stuff, and the implications of that is it's hard to track what's coming from where and when. Could be all
Hmm.
of the above, and we just um, it could. That's where it gets really really weird. Um, and but we can make that make sense. We're onto something, you know.
I kind of feel like the way science fiction and other blockbuster movies have evolved over time, that's served a purpose, whether there was an intent behind it or not. That first you had things like Star Trek to kind of get us thinking about extraterrestrials and stuff, and then you,
Right,
you you fast forward to Marvel and DC, and everything is another reality or another universe, and it kind of warms people up to that, gets it in the zeitgeist, so that if
for
it
sure.
actually happens, it's like, oh, well, that's kind of like that time that,
Yeah,
yeah,
yeah.
their favorite hero does something. Yeah.
And it very much it be like that. And there could be something there. There's a lot of people in Hollywood that might know something, or they're just, trying to get us ready. I know the CIA and other groups have a huge effect on the release of various things. Something that Oppenheimer said shortly after the atomic bomb became a reality, and they were dealing with the implications of the new world they'd created.
Hmm.
Something like about dealing with the implications of this new Buck Rogers world that they were living in now,
Hmm. Hmm.
and people bring that up as soft evidence that he knew about UFO landings or something like that. But um, and that could well be, but perhaps he was privy to um, the weirdness of it all, right? Where the implications of modifying space time could be that the simple explanation would be extraterrestrials from another planet, right?
Mhm.
But
Mhm.
where it gets weird is terrestrials from this planet, but different timelines.
Mhm.
And the same technology. Like if you want to go to another star system, you're going to need some sort of FTL, probably some sort of warp
Mhm.
drive. The implication of that being, though, that you could just as easily potentially go to other timelines of this planet, and that could
Mhm.
be, in terms of traveling to another viable version of Earth, another viable planet for our species. Let's say we reach a point where life on Earth is unsustainable, God forbid. We don't figure out the climate crisis. We don't figure out the pollution crisis. We need a fresh slate, right?
Mhm.
Much easier, because if you know anything about astronomy, the idea of finding an adjacent Earth out there with the right gravity, the right chemical mixture, the right atmosphere, the right biosphere. Not to mention, if you go to a completely alien planet, you just touch down. If you don't have some sort of air filtration, every virus, every spore, everything on that planet is just going to attack you right out the gate, and you're
Right.
going to have the equivalent of a bee sting allergic reaction, just turn you inside out, basically. But that wouldn't necessarily happen if you go to try Earth adjacent, coming from a branch 300,000 years ago.
Mhm.
Let's say where humans went extinct during the Toba eruption or something like that. Didn't end up
Yeah.
panning out.
Yeah. Mhm.
Entirely possible, entirely
Mhm.
plausible. But then you play that the other way around with beings from other more successful branches where they did develop gravity propulsion or space-time
Mhm.
propulsion already coming here. And
Mhm.
that's, what we could be seeing out there. And knowing the implications of, if any of this warp drive stuff is in any way true, these are the implications,
Mhm.
in my opinion. And that's not, weirdly, that's not that far out. Um, and So if you're not dealing with that, then you're not looking at the full breadth of the issue. And then the whole being in astronomy class and be like, what do you think about UFOs? And them saying, well, it's an issue of how they would get here. Um, that kind of goes out the window.
Right.
It
Right. Mhm.
could be everywhere, every when, and even some from here.
Mhm.
Just which here are you talking about? I'm repeating myself, but you get it. I'm glad you get
Yeah, it's all good, and I'm 100% with you on this. Yeah.
it. I'm glad I don't sound like a crazy person
Yeah.
to the science guy. No, but yeah, I appreciate you, dude. And I'm
Yeah.
glad we had this talk. I'm glad to have
Likewise.
another one anytime
Hmm.
soon. And keep in touch about what you're up to, and likewise, if I ever get any lab experiments going, I'll be touching base with you. I'll definitely be picking your brain on experimental design when I get
Sure.
closer to building some of these things myself.
Yeah. Well, if you're doing anything with high voltage, we might be able to lend a hand or make some suggestions. That it sounds like
Certainly.
that group that is always available on APEC is they really know their stuff. That's a talented group.
Yeah, they're. I'm glad to hear you say that. They're doing the thing, doing the
Hmm.
dang thing.
Yeah.
And you are too. So, funding is the issue, and maybe you want to do some crowdfunding or something. I have a little bit of experience there.
Oh, cool.
And
Hmm.
I'm also a web designer and graphic designer, concept artist, and different things too. So, um, I'm sure we'll be collaborating down the road.
I hope so. You're a lot of fun to talk to.
Oh,
You
thanks.
know I've learned a lot just listening to you. You've got a lot of insight, especially into a lot of these characters.
Ah,
Like.
but
But and by the way, the paper that I'm starting with on negative mass, I sent you the title and then the two lead authors on it. Their stuff since and these are materials people. They're not thinking about propulsion, but um, that's to me that's where the interesting connection is between that stuff and then Bob Forward's concept. So that's kind of where
okay. Yeah,
That's
I've
where I'm
opened
going.
several tabs while we've been talking.
Yeah.
Graham Milton is the one I
Hmm.
found on modifications of Newton's second law and
Yeah.
linear continuum elastodynamics.
Hmm.
Cool stuff. And I'll be
And
looking into all of this.
I'm equally as excited about Desiato. That's a rabbit hole I have not gone down before, so I'll have to dig into it and see what he has
Yeah,
to
I'll
say.
have to find his paper. I've got a large collection of papers here
Hmm.
in my hard drive, and I'm not sure
Yeah.
where to find it exactly. But yeah, if you want to just Google warp drive from Maxwell's equations, you'll
Yeah.
probably and Deciato, I'm sure you'll find it. Very exciting stuff. Well,
Yeah. Indeed.
I gotta drive my little guy to preschool and do my day, but definitely
Absolutely.
fun. This is awesome. We'll do it again
Yeah.
soon.
Take care. Good to talk to you, man.
Likewise. Have a good
All
one.
right. All right.
Bye.
Bye bye.